Hey everybody, in today's video we're going to be continuing chapter 10 by finding the area of sectors and the area of segments in circles. So what is a sector? Sector of a circle is basically like a pizza slice. It's got the same shape as a pizza slice. It's basically if you took a slice of a circle and you only wanted to find the area of that one part. The area of a sector is a fraction of the entire circle containing that sector. So to find the area of that sector, whose central angle measure is m degrees, so you can put any number of degrees in there. You multiply the entire area, which you know how to do with pi times the radius squared, and you multiply that by the fraction, which is the degrees of the central angle, over 360, which is a complete circle. All right, so we're going to look at a few examples. So here's our formula. Pi times the radius squared, which is the area of the whole circle, and then times m degrees, which is the fraction, over 360, which is the whole circle. So the fraction would either be right here on this arc, or the fraction would be in here. This is called a central angle. So you want to either look for the number right here or the number right here, and it would be a degree. So let's look at some examples. Find the area of this sector, give the answer in terms of pi, and round it to the nearest hundredth. So in terms of pi means that we're not going to multiply by pi in the calculator. We're just going to multiply all the other numbers and leave pi as the pi symbol. So to find the area of the sector, we find the area of the circle. The circle has a radius of 12, so we do pi times 12 squared. And then we multiply it by the degree of the circle that's shaded in, which is the sector, which is 131 over 360. So r is the radius, which is 12. M is the degree, which is 131. So pi times 12 squared times 131 divided by 360. When we simplify, 12 squared times 131 divided by 360, that's going to give us 52.4. And then we leave the pi as the pi symbol. And then we approximate that by multiplying 52.4 times pi, and you end up getting 164.62. So try that in your calculator. Make sure you're able to get those. First do 12 squared, or you can just do 12 times 12 times 131 divided by 360. You should get 52.4, and then multiply that by pi, and you'll get 164.62. So this first one is in terms of pi. The second one is rounded to the hundredth. All right, let's do another example. So in this case, the circle has a radius of 5 feet, and then the sector is 25 degrees of the circle. So m is 25 degrees and r is 5. So plug that into the formula. Pi times 5 squared times 25 divided by 360. Multiply 5 squared times 25 divided by 360, and you get 1.74. So we get 174 pi feet squared. And then if you multiply through by pi, you get approximately 5.54 feet squared. All right, this next example, we have a radius of 1 meter. And then the sector is 90 degrees, which is a quarter of the circle. So really what you can do is you can just take the area of the entire circle and divide it by 4, since it's just 1/4 of the circle, or we just plug everything right in the formula. M is 90, R is 1. When we do 1 squared times 90 divided by 360, we get 0.25, as expected because it is a quarter of the circle. So it's a quarter times pi meters squared, and then if we multiply, we get approximately 0.79 square meters. All right, and then the next one, finding sector JKL. So the area of sector JKL, this circle has a radius of 16 inches, and then the sector is 36 degrees of the entire circle. So M is 36, R is 16. Multiply through 16 squared times 36 divided by 360, you'll get 25.6 pi. And if you multiply by pi, you'll get 80.42. All right, the next vocabulary word is a segment of a circle, which is a region bounded by an arc and its chord. So the segment of a circle, it looks like this, where it's just this little part here. So this is what we just looked at previously, the entire sector. Now we just want this part. So what we're going to do is, if you look at it, it's actually, this sector is actually made up of the segment part and the triangle part. So what we're going to do is we're going to do the entire sector minus the triangle, and it's going to leave us with just the area of this segment. So let's look at one example. So first we find the area of the sector. So we look at this circle here. We have a radius of 4 meters, and then we have a central angle of 90, so it's going to be pi times 4 squared times 90 out of 360, or 90 divided by 360. So it's just like what we previously did. And then we'll get 4 pi. So the area of the entire sector is 4 pi meters squared. Now we want to find the area of the triangle RST. So luckily this is a right triangle. The radius of this circle is 4 meters, so that means that the base and height are both 4. If it wasn't a right triangle, you wouldn't be able to do that. The base and height wouldn't just be whatever the radius is. It only works when we have a right triangle. So we're going to do 1/2 times base times height, so 1/2 times 4 times 4, and that becomes 8. So the area of the triangle is 8 square meters. So now we know that the entire sector is 4 pi square meters. The triangle is 8 square meters. So now to find the segment, we're going to do the sector minus the triangle, so that's 4 pi minus 8. And that comes out to be about 4.57 square meters. So that's how you find what's called a segment of a circle. All right, so that's it for this section. If you have any questions, make sure you let us know. Have a great day.